Okay, then we're moving from philosophy to the hardcore coding stuff, or maybe we'll have a philosophical view of how to migrate a Spring application to Java EE7. But before I start, how many of you are like Spring fanatics here? Couple of you, okay. Should I be worried? How about Java EE? 1, 2, 3, okay. Well, let's see if I can convince you somehow. First, some words about me. I'm a software architect at Cybercom in Sweden. We're a consulting company. We're operating in the Nordics. We also have office here in Poland. I've been working as a consultant for 15 years, and I've been doing Java development all the way. I'm doing everything from Java ME and Android to enterprise Java, mostly in the enterprise domain. I've also been using a lot of frameworks, and particular Spring. So, I'm not going to say that one of these frameworks are much better than the other, or start a war here, especially since we're kind of a minority here. But what I will do is that we all know that Java EE7 rocks, and yeah, you can fill in the blanks yourselves. So what I'll do here is to do a feature comparison of some selected features of Spring and Java EE, and then I'll do a migration from Spring to Java EE. And this presentation is going to be kind of code and demo heavy, so there will be some switching between slides and the presentation and the code, but I hope you can cope with that. So first of all, I'll give some background of the frameworks, some history. Then I'll just compare them briefly and show which features we're going to look deeply into. And then I'll convert a demo application from Spring to Java EE, and as we go, highlight the differences and similarities, and then wrap up with some lessons learned afterwards. So, some history. Java Enterprise Edition has been around since '98. Then it was called Java Professional Edition, and yeah, nobody really knew about it or used it or anything until J2EE 1.2 came around in '99. And it soon became evident that it's kind of cumbersome, it's difficult, it's a lot of configurations, it's vendor-specific configurations, and nobody liked it, and we were crying for something easier, something lighter, something better. And Rod Johnson launched Spring in his book in 2002. The first actual milestone release came in 2004. And we embraced it, and we used it, and we loved it. Even though it was still kind of XML heavy and configuration, it was much lighter, and it can run without these awful containers. And Sun and later Oracle tried to catch up with the editions of Java Enterprise Edition and started focusing on ease of development and focusing on the developers. And they were kind of following each other, but Spring has always been like a step ahead. Until this year, when Oracle launched Java EE7. And this is the first time that Java EE actually is ahead of Spring and has features that Spring doesn't support, and it's actually easier to use than Spring, and I'll show that in the demo. Spring 4 is due later this year. It is a snapshot build right now, so it's probably just around the corner, and it will cover Java EE7 features as well as Java 8, and then they probably will be a little bit step ahead feature-wise. So a little bit about Spring Framework. The key words there is that it's flexible, and by flexible I mean that you can run it in any kind of application. You can use it in mobile applications, in web applications, standalone applications, enterprise, anything. It's lightweight, you don't need a container. You just pack it and you go. And it's modular, you can pick and choose which functionality of it or which module of it that you want to use. And you can extend it. You can use, it's not a question of using Spring or Java EE. You might as well use Java EE and Spring together. So Java EE 7 that was launched in June this year has three major topics. It focuses on developer productivity, and it's a more cohesive platform, and the APIs are better integrated together, and you have dependency injection by default, and it's less configuration. It's just easier. It has support for HTML5, like WebSockets, JSON processing, and server-side push notifications. And it also meets the enterprise demands. We finally got an upgrade on JMS API, and we have got an API in Java EE for batch processing. So if you look at some of the features of Spring and Java EE, and this is by no means a complete list. This is just a selection, and it's not exclusive in any way. For example, there is no problem using JSF with Spring, or using JPA with Spring, or mixing and matching just as you would like it. But this is just how some of them compares. And the ones in the red frame here is the one we're going to look into in this demo. So, the demo. I'm going to take a typical web-based Spring application and convert it into Java EE. So, if we have a look at it, it's a simple application. It has a web UI, it has a REST API, and since I like cooking and fun of food, it's an online cookbook. So, if we just have a look at how it looks like. It is, since I'm a server-side developer, it hasn't got any flashy UI. It's just a simple one. But it has functionality for listing, viewing, editing, and so forth. So I can edit it as I like. It also has a REST API where I can list the cookbooks or the recipes, or look at one of them, or do a push and posts on it. So it supports all basic functionality that you expect from a REST API and a simple web UI. The data model is simple. It is a user that can own a cookbook or more cookbooks, and a cookbook contains of recipes. So it's not that complex. The application architecture is a neatly layered architecture. It has a persistence layer at the bottom that communicates with a relational database. We have a service layer that uses the persistence layer and provides services for the REST API and the web UI. It's kind of a typical architecture these days, and everything runs in some kind of context. So if we look at the Spring-specific implementation, I've chosen to use here Spring JDBC as the persistence mechanism. And this is maybe not the best Spring persistence mechanism. I probably would have chosen Spring Data or something else, but Spring JDBC is, or has been, the most used one. So I think it's proper to use it in this example. For my service layer, I'm using plain old Java objects. Nothing weird about those. And for the REST API and the web UI, I'm using Spring MVC. Now, I could have used anything else, but this is a pretty normal approach. And everything is wired together, running in a Spring container. So if you look at the code, it is a typical Spring application. I'm using Maven as a build. And I have listed my Spring dependencies here. There are lots of them. And it usually is in a Spring application. Because, let's face it, when you set up a new project, you usually just copy the last one you did, right? And you're not sure if you're using dependencies or not, but you don't want to take them away because you don't know what happens to your application in runtime. It's a web application. We have the web XML file using the dispatcher servlet, and pointing out the Spring configuration location. In in the Spring configuration, we're using a mix of annotation-based configuration and XML-based. And this is kind of on purpose, because everybody knows that you can make a Spring application as nicely and annotated and a minimum of XML configuration needed. But mostly when you do it, you end up with a mix of them. We have the dispatcher servlet in the Spring MVC framework, also using component scan and annotation driven combined with XML configuration. And we have some translations in text file. We'll look at the code in more detail later. So to recap, it's not the only way of doing it. It's not the best way of doing it, but it is a pretty real-life way of doing it. So you can argue that you should have done it this and it's a stupid example because nobody does that anymore. But I know for a fact that most applications, when you use Spring applications, end up being some kind of mix of XML and annotations. Nowadays, you tend to go towards more use of annotations, and that's good. But there's still some XML left. It's clearly based on Spring Framework and is a web application. So what I'm going to do to migrate this one to Java EE is that I'm going to add Java EE as a dependency just to have it available. And then on layer for layer, I'll add the specific Java EE configuration where needed. And I'm going to add the Java EE annotations and remove the Spring annotations. I'm going to do some replacement of the Spring-specific implementations and replace it with Java EE. And then I'll just remove Spring entirely, and we'll see if it runs afterwards. And I'm trying to do a minimum of configurations, and the application will behave just as it did. So if we look at the architecture again, I'll take it layer for layer. And let's start with adding Java EE to make it available for us. Then I'll open the POM file again, and I'm going to add the Java EE dependency. And obviously, it's no time doing all this conversion on stage. It will probably just end up creating a lot of bugs. So I've cheated a little bit and recorded some of it. But I'll tell you exactly what happens. And what happens now is that I add Java EE. And that's all I've done. So now I have Java EE enabled on my application. And by doing this, I get available everything in the Java EE platform. So now I'm able to replace add autowired and the XML injections with add inject, for example. Now, if you're familiar with Spring Framework, you know that from version 3, you can use add inject interchangeably with add autowired, because Spring supports JSR 330, I think. And add inject will be treated just as add autowired. So we start with the persistence layer and have a look at the code and then migrate it to a Java EE counterpart. I have it structured here that I have the data access objects and the JDBC implementations in a package here. And my JDBC data access objects are annotated with the Spring annotation at repository, which is just a specialization of at component. And I inject other objects where needed. And the implementation is using the JDBC template to generate these SQL statements. There's nothing weird about it. I have one for cookbook, one for user, and one for recipe, but they're pretty similar. It also contains a mapping from the result set to my entity object. And my entity object is just a plain old Java class. And the relations are handled by the data access objects. So there's nothing complex about it. So let's add the JPA implementation. So what I'm doing now is that in my entity objects, I'm adding annotations. I'm using the add entity annotations to make it available by JPA. I'm also using a JXP annotation. I'll explain later why I'm using that one. Also, I have annotations for ID columns and the relationships, which are now mapped by JPA for me. If we look at the JPA-specific implementation, it has an add-dependent annotation to make it available for dependency injection. And I inject a helper using add-inject. My helper is just a generified, open the right one, generified version that does the JPA code for me. And I'm using a criteria language to do the selections, like select from entity class, in this case, cookbook. So rather than writing the SQLs like more or less SQL-like, I'm doing here. I'm using a criteria language, but it's doing exactly the same thing. So what I've done here is that I've taken the at repository annotated data access objects and replaced by JPA version of it. And I've replaced the JDBC template code with JPA equivalent code. And I added a persistent XML file, which I forgot to show you, but I'll do it right away. That just maps up my data source. Just shows where I'm looking at my data source. And I've used annotations for the relationships. So it's handled by JPA rather than I have to implement it myself. So what I've done is I've taken the code that looks like this using JDBC templates, and I replaced it with the JPA counterpart. And it's actually pretty similar. It's just another way of writing it. So if we look at the service layer, my Spring services are plain old Java objects. I've annotated them with @transactional and @service. @transactional makes it available for use of Spring transactions, and @service is just a specialization of @component. And it's auto-wiring the data access objects, and I'm just calling the methods on the data access object. So it's a pretty dumb service. So if I turn this into a Java EE counterpart, what I've done here is that I've replaced the Spring annotations with the @stateless. And why did I do that? Well, now I have an EJB. And this is all I need to create an EJB. One annotation. So everybody who's worked with EJBs back in the days where we had to make like 3 interfaces and 2 or 3 implementation classes and an XML deployment descriptor and a specific one for the container we're deploying in. This is an EJB today. It's one annotation. Now, it's a good practice to also make a business interface which I've annotated with @local. And that means I have a local stateless session bin. And if I want to make it remotely available, I annotate it with @remote. If I have a local stateless session bin, I don't need this interface, but it's a good practice to have it. A remote, then you need to have it. So what I've done is that I've replaced the @service and @transactional with @local and @stateless. And if you have read the Java EE specification, or read what features it covers, you probably have noticed that @transactional is supported in Java EE 7. So I don't need an EJB to have transaction support. I could have used the Java @transactional, but here I chose to use an EJB. But if you only need transaction support, you can use a plain old Java object and annotate it with @transactional, and you have transaction support. So what I've done is taken the service classes and replaced the @transactional and @service with @stateless. I also use the @local because it's a good practice to do. But apart from that, it's exactly the same. So let's move on to the REST API. Here I'm using Spring MVC for my API, and it is annotated as a Spring MVC controller, and I'm using the @request mapping to map it to the cookbooks sub-resource. This one. And for every method, I use the @request mapping to specialize what it does, like which method it's used, what does it produce, and do I have any parameters. I can produce JSON, and I can consume JSON. I'm using the @response body if I'm returning my entity objects and I want them to be translated into JSON, like the finder. So this is one way of doing it in Spring. You can do it in any other way, but this is the Spring MVC approach of doing it. So if I translate this into Java EE version, what I've done here is that rather than using @controller and request mapping, I'm using the @path and annotation from JSRS. I'm injecting the cookbook service as an EJB. And this add EJB is the way you look up and use a session bin. So whereas earlier you had to do some lookup and JNDI and portable serialization and everything, this is how you look up an EJB today. That's all it's about. I'm also using the URI info @context to produce the location of the resources I create. And the difference here from the Spring way of doing it is that there is a little bit different way of annotating the resources. Like I have separate annotations for the HTTP methods, and I have a separate method for the path or the variables. And I have producers rather than having it as a parameter in the request method. Apart from that, it's actually pretty similar. So what I've done here is to take the Spring annotations, the request mapping, controller, response body, etc., and replaced it with the JSRS counterparts. Now, I could have used JSRS with Spring, but it would have needed some configuration, and this demo wouldn't have been that cool then. So if we look at the cookbook resource, I have the request mapping annotation for the location, and I'm using the request mapping for annotating my method. The JXRS counterpart is exactly the same information, just spread in 3 annotations, and I'm using that path. What's also important to see here is that I haven't done any configuration in the WebXML file for doing this. What I'm using here is an application configuration that says that it's the @API that the resources are going from. Let's move on to the web UI. And here I've chosen to switch technologies from the Spring to the Java EE counterpart. In Spring MVC, I'm using also a controller class exactly as I did for the REST API. Only here I have request mapping for my list HTML file, which is translated to the JSP files. And I'm adding things to my model object in the Spring MVC model. And my JSP pages look something like this. I can loop over the users. I can access the translations from the translation file, and etc. So it's nothing complex about it at all. So if we look at the JPA version, what I've done here is to rewrite the controller so it's not a Spring MVC controller class anymore. It's just a regular Java object with an @named annotation. And @named is Java server faces way of doing it available for expression language. And I'm also injecting the EJB here, and otherwise I'm just setting things on the model. So if we look at the JSF version of the create file, you can see here that since I'm having the controller @named annotated, I have it available as expression language in the file. And I also have the translation bundle code completion via expression language. Like this one. Otherwise, it's exactly the same page. What I also did here was to change the WebXML file from using the Spring MVC dispatcher servlet to now using the Java Faces servlet. And to support this, I also had to add a configuration file called facesconfig. And that was just used to map up my translations. So this is so far the only configuration I've done. So what I did here was that I replaced the JSP files with XHTML file with the JSF facelet version. I've replaced the controller and request mapping attributes of the controller classes with @named annotation. So rather than having a controller looking like this, it now looks like this. And I have removed the application XML file where I configured where my translations were available and where I could use them. And I have it in the facesconfig file, and I can use it in the same way. So now we have step by step changed the code of all the layers. So now it's time to get rid of the rest of Spring. These configuration files and stuff. So what happens here is that the only configuration file left is the web.xml file and the faces.config file. This template file is just my header and footer used in the other HTML files. And my POM file has changed to only have this dependency. Yeah, we can run it. Yeah, and it still works. And now it's using the faces version. So what I've done is to take a Spring-based web application using Spring MVC for the web UI and the REST API, and using plain old Java objects as the service layer, and Spring JDBC for persistence with a relational database running in a Spring container, and I'll change it to the Java EE counterpart, where I use JAX-RS for REST, JSF for UI, EJBs for the service layer, although I could have used just Bojos there as well, and I'm using JPA for persistence, and it's the same database, and everything is wired together using CDI. And if some of you have used CDI in Java EE6 or previously, you know that you need a beans XML file to get CDI to work. Well, in Java EE7, this is optional. You can have it if you want to do it, but by default, CDI is always enabled. So you have dependency injection by default. So what I've done is that I've added Java EE layer for layer. I've changed the configuration to use Java EE. I've switched from using the Spring MVC servlet in WebXML to Java server faces. I've added a persistence XML file. I've added a faces config file, and I've replaced the Spring annotations with Java EE annotations, and I removed all the Spring configuration and dependencies. So I've gone from a dependency graph looking like this to a dependency graph looking like this. I've gone from a WAR file of 8 megabytes to a WAR file of 50K, if that matters. I've not covered the concept of testing in this presentation. Spring Framework has excellent support for tests, and there's no direct support for this in Java EE7, but there are tools on the market like this. Archillion is a really good option to look into if you need to test, and you do. I've not covered the new aspects of Java EE for JMS, WebSockets, JSON processing, or batch applications. And why should you migrate? Well, Spring is a priority framework. Java EE is a standard. And many Spring applications run in a Java EE container anyway, and why shouldn't you use the container when you have it there? So when should you not migrate? Well, if your target platform is prior to Java EE6, I would recommend stick with Spring. Or if you're deploying it in a non-Java EE compliant container, stick with Spring. If your developers are experts on Spring, stick with Spring. Or if you're using Spring-specific technologies or is heavily based on AOP, you probably should stick with Spring as well. And lessons learned is that migration isn't that hard. They are so similar in the way of doing it. It depends on how your application is structured. And you may have to upgrade to a newer version of Spring to make migration easier, because the newer versions are more similar than the older ones. and not all applications can be migrated. So to wrap up, they're both excellent framework, and listen to your developers. They're the one that are coding, and yeah, Java 7 rocks. So thank you.
Thank you very much. We still got about 10 more minutes, so if you have any questions, you can ask them now. Are there any questions? Okay, I believe there's no questions. Thank you very much for the presentation. And now it's time for about 20-minute break. Thank you.